Good day, everyone. My name is Ola, and today I shall be taking you around the world of mathematics. And today we shall be looking at the topic converting recurring decimals to fractions. But before you put your head into autopilot, I would like to explain what a recurring decimal is by first starting with what a fraction is. Remember, fraction is part of a whole. Take for instance, if I decide to buy an orange and divide it into two, I give you one part. The fraction that you have is 1 out of 2. Now, the first thing we need to do here is how do we convert fractions to decimals? Then I'll be in a position to give you the insight into the types of decimals that we have so that you'll be able to understand the concept recurring decimals. Now let's assume I ask you to convert 1 over 4 to decimals. You agree with me that from our elementary method, we should have 4 here and we should have 1 here. 4 in 1, it's not possible, so you have your 0 there, your decimal point, and you add 0 to this. 4 in 10, how many times? 2. 4 times 2 is what? 8. Then when you subtract 8 from 10, you have 2. 4 in 2 is not possible. You add your 0, and 4 in 20 is what? 5. Then 4 times 5 is what? 20. So when you subtract it, you have your what? 0, 0. And for that reason, 1 over 4 is also given as 0.25. Now, this is a type of decimal that terminates. It has a final number after the decimal point. And for that reason, this decimal is what is called the terminating decimal. So the first type of decimal I want you all to understand or to learn is the terminating decimal. Let's also assume that you are expected to, let's use 2 over 3. Convert 2 over 3 to decimal. We use the same methodology. So we have your 3 here, we have your 2 here. 3 in 2 is not possible. You add your 0.20. 3 in 20 is 6. 3 times 6 is 18. 20 minus 18 gives you 2. You add your 0 again, 6. 18. Another one, you have 2. You add your 0 again, 6. So 2 over 3 is still the same thing as 0.6666 till infinity. For those of you who have time, you can keep writing it as long as you want. But this tends to infinity, and for that reason, we can also rewrite this as 0.6 with this, or using your scientific calculator, you have 0.6 this. This doesn't have an endpoint, and for that reason, this is called recurring non-terminating decimals. So you can see the difference between these two types of decimals, the terminating and what the recurring non-terminating decimal. So we are dealing with this man here, which is what? Recurring non-terminating decimals today. There is also another type of decimal that is pi. If you get the value of pi, you realize that you get the decimals that is non-repeating and non-terminating. So pi falls in the example of non-repeating, non-terminating decimals. So I've giving you 3 types of decimals. We have the terminating decimals, we have the recurring non-terminating decimals, and we have the non-recurring non-terminating decimals. Now, we'll be able to convert fractions to the different types of decimals. Somebody will be asking question on pi before I move forward. Please, it is for calculation and for convenience that you make use of 22 over 7 as pi. 22 over 7 is a rational number, but pi is an irrational number. The value 20 over 7 is used for convenience. And that is why we have that, especially when you want to calculate the area of the circle, the volume of spheres, and the likes. So, but the real value of pi is irrational. So, the next thing after getting this point is to convert recurring decimals to fractions. So, let's have the first question. Convert 0.4 recurring. Now, the dots on each shows that it is a recurring decimal. And if I want to rewrite this thing is still the same thing as 0.444444 and 4 till infinity. Now, there is a rule here. And that rule cuts across every question on converting recurring decimals to fraction. And that rule is that after the decimal point should come the first recurring digit. So let's see if the rule works here. You just let x equals to 0.4. I'm using x because x is a very important letter. That's the most commonly used letter, x and y in mathematics. So I'm using x so that you don't confuse yourself as the case may be, but you can use any other alphabet. So let's use x now. X equals to 0.4. Now the next question you ask yourself is that how many times do we move this decimal point to get the next recurring digit? Now, the first recurring digit is 4. The next is 4. So we are going to move it once to get the next recurring digit, right? So if you move this decimal point from here down to this side, you have 4.4444 like this. And remember, in decimals, if you are moving to the right, the number of times you move determines the number of times you are multiplying it by 10. So since we are moving it once to the right, that means we have succeeded in multiplying this by 10 to get this. And whatever you do on the right hand side, you also do it on the left hand side in an equation. So when you multiply this by x, it's going to give you 10x. Now I have 10 oranges. I decided to give one orange out. You agree with me that we'll be left with 9 oranges. So 10x minus x will give you 9x. This minus this, if this, you cancel these out because they're on the same side of the decimal point. 4 minus 0 gives you what? 4. So the value of x will give you what? 4/9. So if you still doubt this, you can use your calculator. 4 divided by 9, you can see 0.44444. So this is one way to solve problems on converting recurring decimals to fractions. Now let's look at another question on converting recurring decimals to fractions. If you have 0.031, you can now see here we have two recurring digits, 3 and 1. So if I want to write this is still the same thing as 0.0313131 and so on. So we have a whole lot of 31 there. So just as the procedure demands, let x be equals to 0.031. That's the first thing. But from the rule, I said after the decimal point should come the first recurring digit. 0 is not a recurring digit, and it's coming after the decimal point. So what do you need to do? Let's move it to the right once, so that the decimal point now comes here, such that after the decimal point comes the first recurring digit. So if you move it once, you have 0.31, which is the first recurring digit after the decimal point. And remember what I said in the last question we solved, that when you are moving once to the right, that means you're multiplying by 10. So 10 times x gives you what? 10x. Now the next question you ask, you can make this equation 1 if you like. Now the next question you ask is, what do you multiply by this so that we have the next set of recurring digits? Or how many times will you move the decimal point so that we have next set of the recurring digits? Now look at this. The decimal point is already here. So we can only move it once to have the next set of the recurring digits, right? Which is 31, 31 and all that. So if you move it twice, what do you have here? 31.31. Remember, we'll move it 2 times to get the next set of the recurring digits. And since you have moved these 2 times, that means you're multiplying by 100. So 10 times 100 gives you what? 1000x. I hope this is getting clear. Because there are 2 recurring digits here, you move it twice. That is the shortcut to this. If there are 3 recurring digits, you move it 3 times to get the next set of recurring digits. Right? So what is 1000x minus 10x? When you remove 10 oranges from 1000 oranges, you agree with me that you have 990x, which is 990 oranges. This should take care of this. 31 minus 0 is what? 31. So the value of x is what? 31/990. So you can use your calculator to get this to. If you get 31/9, you use your calculator, you divide 31/990, then you have this value. Right, so this